So let's think about what we've done this year. Let me just throw a couple questions. Just relax. I haven't started the lesson. I'm just throwing some questions at you. Finley. Thank you. You don't need that. You don't need that. But anyway, give me the answer.
0.7.
Good. So ones you got to watch out for. Lucy?
Great.
Yeah, you got a 50-50 shot. Remember the negatives in parentheses. That's,
So ridge is 0.25.
yes. Because this would be,
Minus 21.
right. How would you write this using one power? One power. Remember when we multiply two powers, what do we do with the exponents? Yes. Base stays the same, add the exponents. We also did another one. What would that one be? Lucy?
Wait, don't you subtract the exponents?
Yes.
So then you over 11 to the 8.
That is correct. Okay. I mean, that's a big part, that's a big chunk of everything we've done in this unit. All we're going to do today is one more exponent law. When we multiply powers, we add the exponents. When we divide powers, we subtract the exponents. There's one type of question left. Now you can go to 4.5. What happens when we take one power and raise it to another? This is lesson 4.5, not the exercises. That's okay. So let's think about it. 8 to the 4th to the 3rd. Doesn't that mean we got to do 8 to the 4th times 8 to the 4th times 8 to the 4th? We got to multiply this by itself 3 times. Well, 8 to the 4th is this. So you got to take this, 8 to the 4th, multiply it by another 8 to the 4th, multiply it by a third 8 to the 4th. How many 8s am I multiplying by each other? 12. Can you see a shortcut so I don't have to write all this out? Lucy. Exactly. Multiply the exponents. So this is called power to a power. When you have two exponents sort of beside each other, that's power to a power. That means you multiply. So if we've got some power, X and M represent any number, so it could be like, 7 to the 3rd or whatever, and we raise it to another power, keep the base the same, multiply the exponents. Okay? Those are the 3 exponent laws we're going to focus on. So when you multiply powers, you add the exponents. When you divide powers, you subtract the exponents. When you go power to power, you multiply. So a little bit of practice. What would this be? You're not asked to find the answer. You're not asked to evaluate it. Just write it as a single power with a single exponent. What would I do with the exponents? Multiply them. If they're beside each other, right? If one is right beside the other one, it always means multiply. And what happens to the base? Right, so what does the base look like? Like that? Do I need anything else? Brackets. Parentheses. And then 3 times 2. Let's look at C. I know, and then we'll go back. What would this one be? Emily?
6, 7, 14.
Right. Because that means 2 times 7. Just like that means 3 times 2. Okay. Now this one, notice the negative is outside. So my answer is going to start with a negative because it has nothing to do with what's going on here. So it just stays there. But what do I do with the exponents here? Multiply. So the base stays as 2. 4 times 5 is 20. Yeah.
Would you put the graph, the 2 in the bracket?
Oh, you could have it. It wouldn't matter. Like if you had this or this, both are correct. Yes. Say,
So, when you like look at the fraction like this and all this, just like, they just multiply the time.
yeah, whenever you do any one of these exponent laws, the base always stays the same. And then you either add or subtract or multiply.
You want us to find, like, if this question is like this, you want us to find the answer?
Maybe. The question will be clear. It'll either say, if it says write as a single power, that means you just make it into 1 power and stop. If it says evaluate afterwards, then you got to plug it in and finish it. Just like these ones to finish out. So notice the instructions. We want to simplify these as much as we can using our exponent laws. And then once we simplify them as far as we can, then use our calculator and evaluate. So think of your exponent laws. I do in parentheses first, right? What's an easier way to say 3 squared times 3 to the 3rd? 3 to the 5, because I add the exponents. Remember, we multiply, we add. And we still have to raise that to the 3rd. Minus, well, what's an easier way to say that? What's that? It stays the same. It stays as 4. The 6. Yeah, it stays the same. And then square. Well, now we've got the exponents right beside each other, so that should tell you multiply. So this is the same as 3 to the 15 minus 4 to the 12, and that's as far as you can go without a calculator. Yep.
When
Did I make a mistake?
5 instead of 6.
Oh, sorry. Yeah, you're right. I'm mistaken. So that's going to be 4 to the 10. Yeah. That's as far as you can go without plugging it in now using the calculator. And you should be familiar with how to use a calculator or how to use your calculator So these are gonna give you a couple of big numbers, and then we gotta subtract them. So this is gonna give you, 14,348,907. Huh?
3 to the power
So-
15.
Mhm.
3 to the power 15 is that?
Yeah.
Really?
Forget it. Why, what do you think it is? No, it's big. Just like this one is big, but not quite as big. This is 1,048,576. And then I gotta subtract those two to get a final answer of 13,300,331. Can anybody give me the answer to B without even picking up a calculator? Give it to me in less than like 3 seconds. There's something in the question that can tell you exactly what the answer is. Almost. You're on the right track. 0, nothing, really, they're different. 0, no, nothing, no, nada, no, nil, no. You're just telling me different words for 0. Blank. No. Okay. But you're on the right track. You're on the right track. When you raise anything to the 0, what's the answer? 1. So you don't even have to do what's inside here. Because we're taking whatever this answer is and raising it to the 0. So this here tells us the answer has to be 1, no matter what this works out to. Okay? Yes. I know, eh? Wait till you see what I got for you next.
I was enjoying like lunch and everything.
See,
No, it's not this chance.
that could be a lack of sleep.
We're not gonna do this.
Really? What were you doing? I was on my phone.
Actually, my grandma took the word.
Really?
Yeah.
Why's that?
Because I was on it.
I see.
Yeah, but then you're right.
I'm just making promises. Okay,